In order for us to decode this given expression, we need to start with the logarithm of 81 to the base 9. And whatever will be the result of that, we're going to use it to our outer portions, which is the logarithm of whatever would be the result to the base 2, which is equal to x. So again, let's start with the logarithm of 81 to the base 9. Just for the purpose of illustrating this, let us equate this into a variable y. Okay. Now that we have this expression, we could use here the transformation of logarithmic equation into an equivalent exponential equation, which tells us that whenever we have b, which tells us that if we have a logarithm of any expression a to the base b, and when we equate it to a variable, let's say, in this case, it's y. We will not use x because x would be for the general item. This can be transformed or converted into an expression or exponential equation. Specifically, we'll be using the base as its base here. Your variable here, or the equivalent of the entire logarithm, is your exponent, and the expression here is your result. So the logarithm of a to the base b, which is equal to y, can be written as b to the power of y equal to a. So with this, we can rewrite this logarithm here into this form. We have the base is 9, and you have here to the power of y is equal to 81. Next here is to solve for the variable y. We have a property which tells us that if we could express our both sides of the equations into expressions with the same basis, we have it called as the property of equivalent exponents, which tells us that if we have a to the power of m equal to a to the power of n, we have the same values of our bases. We could say that m, the exponent of your left-hand exponential equation or exponential expression or the exponentiation, is equal to the n, which is the exponent of the right-hand side exponentiation. So we can express here 81. So let me have it here. So we still have 9y, and we could express 81 as 9 squared. Now that we have the same basis, we can say that y as the exponent here, which is the value of the entire logarithm here, is just equal to 2. Okay. Now that we have this, we can now substitute this value on the given, because earlier the original given is the logarithm of the expression, which is the logarithm of 81 to the base 9, and with the base of 2 is equal to x. And we are to solve for the value of x here. We know this to be already as 2, so we could rewrite this as the logarithm of the value of the entire expression here, which is 2 to the base 2 is equal to x. Now you can attack this problem in two different ways. Number one is using this transformation. You have 2 to the power of x is equal to the expression here, which is 2. And we know that 2 here has expression of 1, which gives us a result of x, which is the value of the entire given, be equal to 1. That's just one step that you could use here, or you could attack it like this. We have a property for logarithm that if we have the logarithm of any value, let's say b, and to the base b, meaning the expression here is the same as your base, automatically that is equal to 1. And since we have here the logarithm of 2 to the base 2, we have the same value for the base and the expression here. We know automatically that x here is equal to 1, the same result as earlier. So we have now decoded the given equation, a series of logarithm based on our given item. And that's mission accomplished.